Hey guys, Coach Anderson here, and today we're going to talk about the conservation of mass in chemical reactions. Now, by the end of this video, you should be able to answer three main questions. First, you should be able to tell me what information is given in a chemical equation. Secondly, you should be able to describe what the law of conservation of mass is. And lastly, you'll be able to describe how mass is conserved during photosynthesis. Let's go ahead and get started. So firstly, let's talk about what happens when there's a chemical reaction. Now, a chemical reaction is when substances undergo a chemical change and convert into different substances. If you think back to 6th and 7th grade, you might remember the mnemonic "City girls love their cell phones," right? This mnemonic helps you remember the different evidence of a chemical change. For instance, there might be a color change, a gas being produced, light production, a temperature change, the creation of a new substance, or precipitate, which is a solid, being formed. Okay? These are all the evidences of a chemical change. When one of those things happens, a chemical reaction is taking place and something new is being created. Now, we can observe a chemical reaction in a chemical equation. And a chemical equation uses numbers and symbols to show what is happening in that reaction. All of the elements that you see in the chemical equation come from the periodic table of elements. Let's take a quick second to review what is given in a chemical equation, okay? If you look up here, you see that when iron and oxygen react together, we get iron oxide. Now, on the left side of our equation, we call those the reactants. These are the things that start our chemical reaction. These things react together to produce something new. So the left is the reactants. On the right, we have the products, and the products is what is being created or produced. In the middle, we have our reaction arrow. The reaction arrow is also called the yield sign, which means to produce or to result in, okay? So the left is the reactants, the right is the products, and we have our yield symbol in the middle. Now, some other words that you should know is chemical formula, okay? The chemical formula here is iron oxide, right? That's our compound because there's two or more elements chemically combined, right? That's a compound, and it's the chemical formula for an iron oxide, right? And it is represented by the chemical symbols from the periodic table. Now, the small numbers next to the elements are called subscripts, and that tells us the number of atoms that there are of that element. The big numbers that are in front of the compound is called a coefficient, and that tells us the number of molecules that there are present of that compound, okay? So, subscript, small number, tells us the number of atoms. Coefficient, big number, tells us the number of molecules. Left side, reactants, right side, products, and yield sign right there in the middle. All right, let's go ahead and do a quick little check to see if you know what we're talking about. You have a word bank up here and you have a chemical equation. Let's see if you can identify the different parts of the chemical equation using the word bank. All right, if you need to pause this video, go ahead and do that. I'm going to put the answers up here in 3, 2, 1. All right, go ahead and check your answers, see if you got them right. All right, let's go ahead and look at that same equation and talk about how when iron and oxygen react together to form iron oxide, which is rust. How can this chemical equation help us demonstrate the law of conservation of mass? Now, that's a big word, might be a new word, okay? The law of conservation of mass states that mass, is neither created nor destroyed. That means whatever we have on the left side of our equation is equal to what we have on the right side of the equation. Now, the atoms might be rearranged, right? In a chemical reaction, we create new substances. But the law of conservation of mass says that the mass on the left is the same as the mass on the right, okay? The number of atoms on the left is the same as the number of atoms on the right. If I have 55.2 grams on the left, that means I have 55.2 grams on the right in the products, okay? So the law of conservation of mass says that mass is neither created nor destroyed, okay? Both sides are equal. All right, question up here for you. Go ahead and try by yourself. See if you can count the number of atoms in this equation. All right, if you need to pause the video, go ahead and do that. I'm going to put the answers back up here in 3, 2, 1. Go ahead and see, did you get it right? Hopefully you did. You see that we have 6 total atoms on the left in the reactants and 6 total atoms on the right in the products, which means that the law of conservation of mass is true because both sides of our equation are equal. All right, go ahead and think about how mass can be conserved during the process of photosynthesis. Now, photosynthesis is the process in which plants get energy using sunlight, okay? Now, in photosynthesis, which you can see the equation up here, water and carbon dioxide are our reactants. They're on the left-hand side. Now, the energy from sunlight helps cause a chemical reaction with the products being oxygen and glucose, which is a sugar. Now, what you should notice about this equation is that both sides have the same number of atoms, right? Both sides are balanced. And this is because the law of conservation of mass says that mass is neither created nor destroyed, right? It's conserved. Mass is conserved during the process of photosynthesis. All right, one last practice problem for you here. Look at the chemical equation. Now, according to the law of conservation of mass, what must the mass be for the water molecule on the product's side of our equation? All right, go ahead and pause the video if you need to. Use a calculator if you need to. Think about it. All right, hopefully you're saying that the mass of the water on the products must be 8.8 grams, and that is correct because the mass of both the reactants and the products has to equal 35.8 grams, okay? If the mass is equal on both sides of the equation, then you are correct because the law of conservation of mass states that mass is neither created nor destroyed, right? Both sides of our equation have to be balanced. All right, thank you guys so much for watching today. I hope you learned something new about the conservation of mass and chemical reactions. Remember to be kind to one another, make good choices, and I look forward to seeing you back in class.